Hello, welcome. I'm Andreas, your tech-curious web designer. In this video, we will compare two popular databases used with Django, SQLite for development and PostgreSQL for production. We will look at what the individual strengths and weaknesses are, how to set them up locally, and I will show you two features which are available on PostgreSQL but not supported on SQLite. But before we get started, if you like this content, give this video a thumbs up, subscribe to this channel and click the bell icon. This helps me to grow this channel and to reach more aspiring web developers. And if you want to support my work financially, you can subscribe to my Patreon page and get access to exclusive content. Thank you so much. I really appreciate you. Okay, and now without further ado, let's dive in. A big thank you to CNode for sponsoring this video. CNode is a cloud-based application deployment platform that makes deploying your Django app and connecting it with a PostgreSQL database easy and affordable with a 7-day free trial. Check out my CNode tutorial to learn more. First, let's look at some strengths and weaknesses of each database. So SQLite's strengths are it is lightweight and easy to use, no server needed, just a single file, 0 configurations, portable with your project, and is built into Python with the SQLite 3 module. The weaknesses are it has no multi-user support, it's missing many advanced features, it struggles with large and complex datasets, and it has limited security. The strengths of PostgreSQL are that it is a fully featured SQL database, supports multiple concurrent users, it can handle complex queries and large datasets, it has strong data integrity and security, and it scales very well. The weaknesses are that Postgres requires a server or a container to run, it has a more complex configuration and setup, and is much heavier on resource usage. Therefore, the best use cases for SQLite is in local development, when building prototypes, mobile apps, single-user desktop applications, or testing. On the other hand, Postgres is best for production when building complex multi-user applications, using APIs and backend services, data analysis, or building a Django app using advanced features. And now let's take a closer look at two of these advanced features. One such feature is the ArrayField, that lets us store a list or array of values in a single database field, separated by commas. On the front end, we can treat each of these values like individual items and loop through them. And the second feature is the SearchVector, that allows full text search, for example on articles. This is a much more powerful and smarter search than just looking for exact words. For example, if I search for the term code, it finds this article, even though the exact word code does not appear in the article. But it understands that the word coding, which is in the article, is related and has the same stem or root. Under the hood, this is using the PostgreSQL's full text search engine to make smart searches. On the other hand, if we search for the word the, which is in the article, we get no results, and that's because it ignores stop words like the, but, or this. Alright, now let's look at the code for these examples. Here I'm inside an empty folder in Visual Studio Code, and first let's install a basic Django application. And for this we can use my Django starter code and can download it from github.com/ndjut/django-starter. Here we copy this git clone command, open the terminal, and paste it in here. Then we create our virtual environment and activate it. Then I install the dependencies from the requirements.txt file. And migrate to the built-in SQLite database. Then I create the superuser change quickly the title for this project. So I'm going to the core folder, to settings.py, and change the title here to PostgreSQL versus SQLite. Okay, and then I start up the server. And this is our basic Django application running on localhost colon 1000. Let's log in. And add a user profile for SQLite. Awesome. The setup for the SQLite database is finished. Now let's add the Postgres database. The simplest way to set up a Postgres database is to run it inside a Docker container. And for this we can use Docker Desktop. Here download the version for your operating system. And here we have Docker Desktop running on the computer. Next, let's create a Docker Compose file to spin up a container with the Postgres database. So in the project root here, I create a new file, docker-compose.yaml. And here we have the basic configurations. I give this project on Docker name, so Django with Postgres. Then I define the service. I name it Postgres. I download the Postgres image from the Docker Hub. I give the container the name my Postgres container. Open the ports on 5432 and add the database name, user and password. And then I run docker compose up-d. This is downloading the Postgres image and spinning up the container with the Postgres database. And here we have our container up and running. Now let's connect it to our Django application. I go back to the settings.py file. Here to the database configuration. I create a using Postgres variable and set this to true. So if this variable is true, I use the PostgreSQL database. I configure the engine to use PostgreSQL with the name Postgres, user Postgres, and password Postgres, host localhost, and the port 5432. Else we use the SQLite tree database. Alright, and lastly we need to install the PostgreSQL driver psycopg2 binary. And with this we have connected to the Postgres database. Now let's do the migrations. Then I create the super user for the Postgres database. And start up the server. Then log in. And add here a profile for PostgreSQL. Great, now both databases are set up. Excellent!
Excellent!
Now let's look into the features. First up, the ArrayField. I'm going to my home folder, here to models.py. Then I import the ArrayField from django.contrib.postgres.fields. Create here a post class with a title and a text property, which is using this ArrayField. And each item in this ArrayField is a char field. Add the string representation of this model and save this file. Now let's do the migrations. Python manage to py make migrations. Then migrate. And start up the server again. Then I go to the admin.py file to register this model. From models import post and register it for the admin panel. Okay, save this file. Next, let's go to the admin panel and add a tag list. I log into the admin panel and here to posts, add a new post and add here tag list with the tags separated by commas. Okay, save. Then let's display them on the home page. So I'm going to the views.py file, import the post model, then fetch all the objects from the post table and pass it to the template. Okay, save this file. Then we go to the home.html file. This is in the template folder. Here home.html. Add here title. And add here loop. I loop through the posts object with for post in posts. And inside the post, I loop through the tags. For tag in post.tags. And display the tag. Okay, save this file and let's check it out. And as we can see here, our 3 tags, which are basically one string in the database, are rendered as individual items. Now let's have a look how SQLite would solve this. So I switch the database to SQLite. In the settings file, I switch this variable to false and save. We get an error message because this table is not created in the database. Let's do the migration. But as expected, we got a syntax error because the array field is not supported in SQLite. An alternative to the array field is the JSON field, which is supported in both databases. So I'm going to the models.py file, remove the array field, and instead use a JSON field. Okay, save this file. Now let's modify our migration file. And this is the migration to the Postgres database, and it would raise an error because of the array field. Let's change this to the JSON field. Okay, save this file. And now let's do the migration. And run the server. Now let's add a tag list to the SQLite database. Add a post. And if we try to add a string like this with just commas, we get an error because this is invalid JSON. A list in JSON is written in square brackets and double quotes. Okay, save this file. And let's check out the homepage. Alright, and here we see the same result as when using an array field, but instead of a simple string with commas, we need to add it as a JSON object. Now let's switch back to the Postgres database and change it to a JSON field there as well. Back to the settings.py file, change it back to Postgres, then we go to the models.py file, and here we see an error, because Django expects the value in JSON format in the database, but we have added the list as a normal string. And in order to get rid of this error and access the database to change it to a JSON format, I temporarily change this field to a text field, which allows any type of input. Okay, let's save this file, and let's make the migrations. Migrate, and run the server. And as we can see, since it's looping through a string now instead of a list, each character is displayed separately. Now let's log into the admin panel. Here we see the format for the array field. And change this now to the JSON format instead. Okay, save this file. And now we can switch back to the JSON field. Okay, and again make the migrations. Okay, nice. Now let's look at another feature which only works with Postgres. And this is the SearchVector, which allows for full text search. I create a new model class, this time an article, again with a title, and content as a text field. Save this file. Let's do the migrations. And spin up the server. Then let's register this model. Save this file. And let's create an article in the database. I add a title and the content. Save this article. Then I'm going to my template, add some spaces, then a title for SearchVector, then add here a form with a search field. The name of this input field is Q. If we got a query from the backend, we show here the value, otherwise by default is blank, and a placeholder. And underneath we got the query. We show the results by looping through the articles, displaying the title and the content. Otherwise, with no results, we show no articles found. Okay, save this file. Now let's create a backend. So back to the views.py. Here I import the search vector from django.contrib.postgres.search and also the article class. Here we get the search query from the frontend through the Q parameter. Then I add here the results. First we have an empty list. And if we have a search query, I use here the search vector to find articles where the search term is in the title or in the content. And add the articles to the results. And then add the query in the results object to the context. Okay, save this file and let's check it out. Here we have the input field to search for articles. Let's search for Python. And as we can see here, it found this article, because Python is in the title. It can also find 2025, because it's in the content. But when we look for Django, no articles are found. If you search for language, the article is found again. But if you search for languages with the S, the article is found too, because full text search uses stemming, which understands the root of a word and matches also variations. But on the other hand, if we search for the, which is included in the content, no articles are found, because it ignores so-called stop words. But when we search for code, which is not included in the content, but we have coding here, it again finds the article. And it can also find articles containing multiple search terms. Pretty cool. Okay, now let's see what the alternative is for SQLite database. First, change again the database. Then we go to the views.py file and remove the search vector. And instead of using the search vector, we can use Django's Q object for searches with the SQLite database. With Q we can build complex queries, for example using icontains to search the title and the content field. Let's import Q from django.dp.models. Okay, save this file. Then let's migrate to add the article model also to the SQLite database. Spin up the server. Then let's add the article in the database. Then we go back to the home page and test the search. Again, let's search for Python, and it finds this article. Django correctly doesn't give any results. Then let's search languages. This worked with the SearchVector. But here we see the difference, because icontains only can find exact words, and it's not a smart search. Let's try with the, and the article shows up, because it can find the word. What about code? No, it can't find code, but it finds coding. And also the search with two search terms is not working right out of the box like a full text search with SearchVector. Alright, these are two powerful example features that only work with PostgreSQL. If you want to implement them in your project, you will need to connect to a PostgreSQL database also in development. But this is all for this video. Thank you so much for watching. If you like this content, give this video a thumbs up, subscribe to this channel, and click the bell icon not to miss the next one. I hope to see you there. Until then, stay curious, my friends, and bye bye for now.